Hello friends, today we start with syllabus of 11th class physics. The first unit of this syllabus is physical world and measurement. It comprises of two chapters. First chapter is introduction to physical world and the second chapter is units and measurements. So first we start with introduction to physical world. The first question is, what is science? Since we are to study physics, so physics is a branch of science, so we must know the answer to the question, what is science? The word science has been derived from Latin verb scientia, which means to know. To know words refers to methodology. It refers to a methodology to acquire knowledge. Thus, science is a systematic knowledge acquired through scientific method. So what is science? It is a systematic knowledge acquired through scientific method. Now what is scientific method? Let the sentence complete. You will get the definition of scientific method. So what is a scientific method? An organized attempt to acquire knowledge is called as scientific method. Method means an organized attempt. For what? To acquire knowledge. An organized attempt to acquire knowledge is called as scientific method. Now question arises, what are the steps involved with scientific method? Now what are the steps involved in scientific method? First step is observations. We are provided with senses and our senses make observation around us in the environment, and the first step that we are to take up is observations. We are to record observations. Whatever project we are undertaking, whatever topic we are discussing, we are to record observations. Second step is reasoning. Second step is reasoning. Third step is model making. And the fourth step is theoretical predictions. So the four steps are involved in scientific method. The first step is observation. Second step is reasoning. Third step is model making. Fourth step is theoretical predictions. Now question arises, what is a theory? Normally we have been talking about theory and practical. So what is a theory? So what is a theory? If the behavior of a physical system is explained in terms of limited number of laws, it is called as a theory. What is a theory? If the behavior of a physical system is explained in terms of limited number of laws, it is called as a theory. Now validity of theory. If a theory is able to explain satisfactorily most of the relevant measurements, it is valid, otherwise not. So how a theory is valid? How we call this theory is valid? If a theory is able to explain satisfactorily most of the relevant measurements, it is valid, otherwise not. Now discrepancy in a theory. Sometimes we find discrepancy in a theory and then theories have to be modified, and then how we detect discrepancy in a theory. Sometimes our observation does not match with theory. So let us look at. It may happen that a new observation or measurement reveals a discrepancy between existing theory and the observation or measurement. When there is a discrepancy in a theory, then theory has to be modified. Okay. So, it may happen that the new observation or measurement reveals a discrepancy between existing theory and the observation or measurement. Even if the discrepancy is small but is significant, then the theory cannot be accepted. It may have to be refined or modified. Now, modification in a theory. How theories are modified? Let us see. If the modification in theory cannot still explain the significant difference, then the theory have to be discarded and a new theory has to take its place. In all branches of science, such small discrepancies have given birth to new concepts and new theories. We are familiar with how these have been done. Okay. Now, modified theories. Let us look at modified theories, how theories are modified. The concept of flat earth was replaced by the concept of spherical earth. So, previously the earth was treated to be as flat, but now it is treated to be as spherical. So, the theory has been modified. So, the concept of flat earth was replaced by the concept of spherical earth. Similarly, geocentric theory, imagining earth to be at the center of the universe, was replaced by the heliocentric theory, imagining sun to be stationary and all planets revolving around it. Now, third, corpuscular theory of light given by Newton was replaced by Huygens wave theory of light, which was replaced by Planck's quantum theory of light, and finally dual nature of light was given by Einstein to account for all the phenomena observed in case of light. And so many others theories we have which have been modified. These are some of the examples of modified theories. Now, various discoveries that we are to discuss during this topic on how theories were modified and progressed. So, let us see. First theory, discovery of heliocentric theory of solar system. Second, discovery of electromagnetic waves. Third, discovery of dual nature of radiation and matter. Fourth, discovery of electrons. Fifth, discovery of isotopes. Sixth, discovery of neutrons. And seventh, discovery of modern atomic model. And eighth, discovery of present day atomic model. So, these are 8 discoveries that we are discussing under scientific method, how scientific method was applied to discover these theories. Okay. Now, some questions are there. Question 1, question 2, question 3, question 4. Question number 1, what is science? Question number 2, define scientific method and mention steps involved. Question number 3, what is a theory? Question number 4, how discrepancy in a theory is detected, modified or discarded? You answer these questions by the time we discuss first discovery of heliocentric theory. We go back to Aristotle. Aristotle 384 to 342 BC. He said that all bodies in this universe are at rest. He said natural tendency of bodies is to remain at rest. Aristotle in 384 to 342 BC said that natural tendency of bodies is to remain at rest. Then Ptolemy came 200 AD. He propounded geocentric theory of solar system on the basis of Aristotle's observations. Then Copernicus came 1473 to 1543 AD. He said that he propounded heliocentric theory but did not give any proof. So this is how discovery of heliocentric theory progressed right from 384 BC to 1543 AD. 1500 years. It took 1500 years to modify the theory, geocentric theory of solar system. Almost 1300, 200 AD, 200 AD and 1543. You can say almost 1343 years took to modify this theory, geocentric theory of solar system. Now, confirmation of heliocentric theory by Galileo Galilei. His time period was 1564 to 1642 AD. He stated on the basis of simple experiments on an inclined plane that natural tendency of bodies can also be to remain in motion, and confirmed the existence of heliocentric theory. Now, Aristotle said natural tendency of all bodies is rest. He did not mention about motion, but Galileo Galilei said natural tendency of bodies can also be to remain in motion. He added to Aristotle's theory the word motion. The natural tendency of bodies can also be to remain in motion, and confirm the existence of heliocentric theory through simple experiments. So it's a simple experiment on an inclined plane. Now, first diagram shows that the ball on extreme right goes to equal height. In the second experiment, when the angle of inclination is reduced, the ball goes a little higher, covers little longer distance on inclined plane. And in the third case, when the angle of inclination is reduced further, then the ball again goes much more longer distance on inclined plane. The horizontal distance covered in the case of case 1 is less. Horizontal distance covered in case of 2. Here you can see horizontal distance in case of 2 is more, and again horizontal distance in case of 3 is again more. Now, horizontal distance covered in all the 3 cases. Here we have some words coming up. First experiment. Observations. Horizontal distance covered in first experiment is less, second experiment is more, third experiment is still more. This shows that if forces like gravitational force and frictional force. So what were the conclusion drawn? The conclusion drawn were, if external forces like gravitational force and frictional force are absent, the ball, once released from certain height, would cover infinite horizontal distance on horizontal plane. On the other side, that is, it would remain in motion forever. Then natural state of bodies can be motion also. So this was the conclusion drawn. Therefore, natural state of bodies can be motion also. Natural state of earth is motion and not rest. It is going round the sun and the sun is not going round the earth. He was imprisoned for this promulgation, but his theory was true then and is true today, verified by Kepler's laws. Then geocentric theory was discarded afterwards. Galileo's law of inertia. Now, on the basis of Galileo's observation, he stated the law of inertia. The statement is like this: all bodies have tendency to preserve their state of rest or of uniform motion in a straight line. Then Isaac Newton came, 1642 to 1727 AD. On the basis of conclusion drawn by Galileo, Newton stated first law of motion. Everybody in this universe continues to be in state of rest or of uniform motion in a straight line unless it is compelled by some external force to change that state. Now assignment 1. Question number 5. What is the contribution of Aristotle, Ptolemy, Copernicus and Galileo Galilei in developing heliocentric theory? Question number 6. State Galileo's law of inertia. Thank you so much for listening patiently to this lecture. God bless you.